Hi everyone, welcome to the Politics, Perception and Philosophy of Physics Autumn Semester 2020. This is the first video proper after the video introduction I uploaded a few weeks ago, and I'll give you a bit of an overview obviously of the module, how it's going to work in terms of the assessment, etc. Give you a broad sort of brush outline of the various topics we're going to cover, but what I want to stress is that in previous years, and especially this year, you get the opportunity to drive this module a great deal in terms of where the discussions play out, and also in terms of your choice of coursework, for reasons I'll discuss soon. So, myself and Penny Gowland are co-convening this module this year. Usual email addresses, firstname.lastname@nottingham.ac.uk. Contact us whenever you like with queries about the module, and we'll do our absolute best to get back in touch with you within 24 hours, either to address the query completely or to set up a Teams meeting, one-to-one Teams meeting to discuss it. Before I go any further, I need to credit the source of that background image on the first slide, and it's going to be used in quite a few slides during the presentations, during the video presentations for PPP. I'll also slip into the abbreviation PPP because the Politics, Perception and Philosophy of Physics is a bit of a tongue twister, so we'll stick with PPP. The background, which is basically a microphone, it's that image that you can see in front of you there, is taken from this post at The Conversation. What's at risk if scientists don't think strategically before talking politics? And that's one of the key motivations of PPP, is to get you to think about communication, not just communication in a technical scientific writing sense, which you've got through project reports and lab reports, etc., but getting beyond that to think about communicating to a much broader audience right across the board, be it politicians or be it school children, whatever, writing for a range of different audiences and thinking carefully about how we make a scientific argument, because the painful thing to realize as a scientist, and it's particularly clear, in recent history, that just providing the data and the evidence and the scientific facts, however they might be defined, is not enough. It really isn't enough, and worse, often actually presenting the evidence can cause somebody to be entrenched in the previous view they held, previous possibly anti-science view they held. So it's clear that we need more than the data and the evidence, and we've got to think carefully about how we communicate. And that's really one of the core drivers for PPP. We're going to think about philosophy, we're going to think about politics, we're going to think about communication, we're going to think about the interface and the interplay between those three. Okay, how's it going to work? So, going to have the delivery of the primary content via videos like this. There's going to be I think 11 of them, 10 or 11 of them. I've set up a dedicated YouTube channel, but the videos will be embedded directly in Moodle as well. We have our synchronous sessions on I'll say that again. We have our synchronous sessions on Mondays at 4 p.m. My apologies, I believe I said that wrong during the fourth year overview. When was it? Yesterday. I lost all track of time. I think it was yesterday, where I said maybe 10 or 11. I'm sorry, it's actually 4 o'clock. It's right on the Moodle page, it's right here, and I'll send round an email via Moodle as soon as I upload this video, just to hammer that home. It is Mondays at 4 p.m. I will use WordPress as well to write blog posts that accompany the material. There is also f34ppp.com, which I'll get back to, where there are lots of previous examples of student blog posts and student writing and student articles. More on the coursework soon. All communication and admin is obviously via the wonderful Moodle. Okay, here's an overview. Here's what it looks like this year. We're going to kick off with the provocative title, as you might have seen, called Science Proves Nothing. We'll get onto that and I'll explain just where that's going very soon. And then you can see you can pause the video at this point and have a read down if you want. But you can see the list of different types of titles we're going to look at. We're going to actually, as you can see, on November 16th, I've got something called The Death of the Lecture, which is pretty timely given the current circumstances. And I think PPP gives us a good opportunity to get your feedback, particularly a little bit further into the semester like that, on how well or how badly you think this whole online environment is working. Then the week after that, we have an invited speaker, Harry Collins. This is Harry. You can read all about him at that URL. Please go and visit it. He's a fascinating chap. He's a sociologist. As you can see, sociologist fools physics judges. This is from Nature a few years back, or quite some time ago, back in 2006. Oh my, 14 years ago. And Harry was, I guess the best word, embedded in the LIGO, in the Gravitational Waves project. So he followed it all the way through for damn near 40 years, more than 40 years, I think 42 years, fittingly enough. And he's seen the evolution of that project over the years, and his book, which is there on the screen, Gravity's Kiss, thoroughly recommend you read that. It's a wonderful insight not only into the physics, and as you know, the gravitational wave physics is incredible, but the social dynamics underpinning how the research progressed, but also how it was communicated. Well worth a read. Very, very closely linked to the themes of PPP, as are Harry's other books. That's just 3 of them. There are many, many books that Harry has written. Are we all scientific experts now? Absolutely core to the PPP message. And as you can see, tacit and explicit knowledge. So Harry will be visiting us virtually on the 23rd of November. And let me just check that. Yeah, 23rd of November. And I'm looking forward immensely to that. There is also another invited speaker to be confirmed. Hopefully I'll be able to announce that next week. Lots of other recommended reading. So PPP is a very different module. It's not going to be you read the stuff and then you're assessed on the stuff. That's not how it works. A lot of the coursework is actually driven by you. You get to choose, not a lot, all of it, if you want, is driven by you. You get to choose the topics you write on. Obviously, they have to be linked to the themes we're discussing in PPP. In terms of the recommended reading, it's important, obviously, that you read around the subjects we're going to be talking about. I will give you links to posts and articles, etc. I'll advise and recommend different things to read. But if you really want to get the highest marks you can in the articles, or indeed if you want those articles to end up being published in Physics World, which quite a number now have been from PPP in recent years, I'll get to that as well in a second. You need to obviously inform yourself about what the arguments are, and to do that you need to be aware of the broader context. So there are, as you can see, quite a few books I recommend here. In terms of the whole idea of philosophy of science and how science works and the scientific method and whether there is a generic scientific method, all those types of questions. 3 key books there. Chalmers' What is this thing called science? Ladyman's Understanding Philosophy of Science, but it's written from the perspective of somebody who has a background actually in maths and mathematical physics. It's written in a way that resonates with physicists, let's put it that way, which is not always the case for some social science books and philosophy of science books. I also very heavily recommend Okash's Philosophy of Science, a very short introduction. Compact book that gives you the key themes and the key concepts and the key arguments and the key controversies. Okay, then 3 books at the bottom here. 2 by the same author, Angela Saini, Superior and Inferior, on the science of gender and the science of race, and the pseudoscience of race and the pseudoscience of gender. Thoroughly recommended. Superior in particular, well, no, not in particular, both of them are great books. Superior has actually won a whole host of prizes, including Times, I believe. I apologise if I'm wrong. Times Book of the Year, Guardian Book of the Year. Well worth reading. Finally, Death of Expertise by Tom Nichols. Fantastic book. As you can see, the campaign against established knowledge and why it matters. Core importance for PPP. Range of additional resources available via the PPP website, which is F34PPP. Okay, some suggested article topics. Just before I get on there, just on the right-hand side, what I aim to do, it doesn't work out every year, but it's worked out for quite a few years, as you can see, 4 years of PPP, is to take some of the best coursework articles, send them to Physics World, send them to the editor of Physics World and the features editor, see if they're interested in publishing them, and fortunately enough, for a number of years, for 4 years, they have published them. Andrew Coe, A New Mindset. Aaron Iftikhar, Is Physics Just for the Rich? Luke Sibbett, who was the first, Creating Better Opportunities. And then just very recently from last year, this one isn't published yet, but hopefully it'll be coming out soon, OK Boomer, The Generational Divide in Climate Science. I'm really, really, really happy that Nottingham undergraduates are producing, and now graduates, are producing work of that quality, that it can go into physics world. And it's not like these are dramatically edited or ripped apart. They go in pretty close to the original coursework, and it's great. So hopefully one of you listening now will end up published in Physics World as well. Maybe one or more, we'll see. So some of the topics are listed there, but again, I stress, you have the option of suggesting your own topic, and as long as it's connected in with the themes of PPP, that's fine. So just ask you to contact myself or Penny just to run it by us. So over the years that PPP has been running, I can really only think of a handful of topics that have been outright vetoed. So as long as you're broadly within the themes, and the themes are broad, as we're about to see, you'll be fine, but just run it past us first. Okay, so there are just some of the topics you can see related to: should scientists have to justify research in terms of its economic or socio-economic impact? Social media and its role in terms of scientific progress. Should we be announcing results via Twitter? Should we be holding press conferences before we go through peer review? That type of thing. When is it appropriate to debate and when is it not appropriate to debate? Is multiverse theory scientific? I have my own particular views on that. You may have yours. Can science be crowdfunded? Is peer review working? We're going to look at peer review in quite some detail. Should universities cut back on PhDs, which was actually the subject of Luke's article, as you can see, Creating Better Opportunities, back in 2014. And we're going to have a whole session on this, but is the university lecture dead? Have we gone into a brave new online world, never to return? Stress again, great deal of flexibility in topic choice, and I look forward this year, as every other year, to reading your suggested topics. I learn a lot from reading the PPP coursework. Okay, a bit of a public service announcement. I don't quite know what else to call this. There's been a lot of hand-wringing and agonising and pearl-clutching about the indoctrination, is the term that's used, of students by left-wing academics in universities. There's something called Turning Point USA and its UK wing called Turning Point UK, unsurprisingly, which is all about shopping left-wing academics and saying they've been teaching this to students and students can't think for themselves, therefore they're being brainwashed. We want you to speak your mind. Be you left of centre or right of centre or far left or... okay, maybe not. But we want you to put across your views as openly as possible, and you are not going to lose marks for views that don't align. I need to stress this, for views that do not align with myself or Penny. You're not going to lose. You are going to lose marks if your arguments are put forward poorly, if you don't cite references, if you don't cite sources, if you just write off the cuff with no coherence, if it's a stream of consciousness. Those are the reasons you lose marks. But if you put across a coherent argument that happens not to align with my politics or ideology, and we all have an ideology, then that's fine. And indeed, so for example, just to hopefully allay your fears on this a little bit, I am not a person of faith, but we've had a number of articles over the years which have been about religion. And I've certainly not agreed with those articles, but those articles have been given very good marks because they were well argued in many cases. And indeed, I've had much more productive arguments with people of faith than I've had with quite a few deeply, staunchly atheists. So I want to allay your concerns. So, as Turning Point put it, it is indeed about questioning and challenging and fighting back and putting your opinion across. Indeed, one thing I've worried about over the years is that we've all been it's a bit like preaching to the choir too much. So, anytime you've got any dissenting opinions and you want to argue with me or you want to argue with Penny, please do. That's what this module is all about. If you want to argue, please do. I remember speaking with a colleague here in Nottingham who's in philosophy. He's also very interested in physics. And I said, well, why did you end up going down the philosophy rather than the physics route? And he said, well, actually, it's because I really, really like to argue. That's why I decided to do philosophy. So it's about argument and debate and discussion. So not about myself or Penny being the source of wisdom and knowledge that we provide. It's all about interaction and engagement. Just a little bit more on Turning Point because it's very funny. A few years back, the Times Higher reported, as you can see, Times Higher Education, which is an important magazine, journal, whatever you want to call it, for higher education in the UK and around the world, exposing crazy radical professors. This is Turning Point UK. 12 of the best troll prof watch list tweets. So obviously the Twitter sphere got on top of this and trolled it very, very heavily. So you can see the one on the right, which particularly amused me. Supposed student who's putting this in, first name's Sherlock, last name's Holmes, and the professor that he is shopping and reporting to Turning Point UK is James Moriarty, and the reasons why are because of perpetual mischief and for taking over the enterprise by living in the holodeck, which is just wonderful. What's science? If you had to define science in a sentence, what would you say? It's a really difficult question to answer if you think about it. What's the scientific method? Why do we do science? It's not just a technology driver, although it drives our technology. This idea, which is called the linear model of innovation, which we'll get to, and scientists love it because if you're working in fundamental science, you've always got a justification for what you're doing, regardless of how useless it might turn out to be. And how would we define useless? But the idea that you have basic research, fundamental research, looking at blue skies, curiosity-driven research, and that leads into applied research, and that leads into a product, and that leads into marketing, and that leads into manufacturing, etc., etc. This nice linear chain doesn't work like that. Countless examples of where it doesn't work like that. In fact, one of the first, you spent a lot of second year doing statistical mechanics and thermodynamics. Thermodynamics is the best example of where the engineering problem came long before the fundamental science. It was the engineering that really drove and the application that really drove the fundamental science, not the other way around. Thermodynamics, steam engines didn't pop out once we understood the science of thermodynamics. It's the steam engines were appearing and we were trying to understand them to make them better. So it's much more like a feedback loop where discovery, application, or application, then discovery of just how this works. Often in the lab, something will happen, particularly in condensed matter physics, and you go, okay, I don't understand that. You get in touch with your theory chums, and they'll say, no, we've no clue what's going on either. And there begins a process of where the experimentalists talk to the theorists talk to the experimentalists, and it goes round and round and round, and we fine tune, and they suggest different experiments, or we suggest different experiments, they suggest different theories, we suggest different theories, and we work together, and it's much more like a feedback loop. But what's certainly true is that, just down in the bottom left there, knowledge is power. How is scientific knowledge different from other forms of knowledge? Can we define the scientific method? And indeed, is there a scientific method? Is there an archetypal, generic scientific method? Does every scientist do science the same? I think you'd probably agree, no, there isn't. Which then, if different scientists are following different recipes for science, what does that say about capital T, capital S, capital M, the scientific method? Hopefully we'll address these questions. Well, I don't know whether we'll answer these questions, but we'll certainly discuss these questions on Monday. The other aspect of this, is science completely rational and logical and objective? There is that quote that I keep mentioning every year in, year out from Feynman. Science is the belief in the ignorance of experts, and we get nice warm cozy glow as physicists because we go, yeah, it's all about the maths and it's all about how everything is really defined and logical and rational, and it all couples together and it's beautiful, except most of the time it's not. Most of the time it's messy as hell. So this is from Ladyman's book. Rightly or wrongly, science is often thought to be the ultimate form of objective and rational inquiry, and in many ways it is. And scientists are widely regarded as being able to gather and interpret evidence and use it to arrive at conclusions that are scientifically proven and so not just the product of ideology or prejudice. The idea that science is completely free of bias, the idea that science is completely free of ideology or prejudice or petty human squabbles, indeed, is something, if you're still holding on to that, I hate to disillusion you, but disillusion you I must. Because science has certainly got its own set of biases. Moreover, leaving the biases aside, science isn't about certainty. It's never been about certainty. This is a wonderful interview with Carlo Rovelli. Rovelli's written a number of great books. He's one of those writers who I'm sure spends more time editing than writing, and that's a cornerstone, a hallmark of good writing. This is Rovelli. The very expression scientifically proven is a contradiction in terms. There is nothing that is scientifically proven. The core of science is the deep awareness that we have wrong ideas, we have prejudices, we have ingrained prejudices. Everybody does at some level. In a conceptual structure for grasping reality, there might be something not appropriate, something we may have to revise to understand better. And I know there are some sides of the web would think, well, this is all just woke social justice talk about science. Science is, of course, completely objective. This is Feynman, the physicist's physicist, back, in the late 60s, early 70s. It is imperative in science to doubt. It is absolutely necessary for progress in science to have uncertainty as a fundamental part of your inner nature. To make progress in understanding, we must remain modest and allow that we do not know. Nothing is certain or proved beyond all doubt. Just echoing, Rovelli's echoing Feynman, of course. You investigate for curiosity because it is unknown, not because you know the answer. And as you develop more information in the scientists, it's not that you are finding out the truth, but you are finding out that this or that is more or less likely. Wonderful quote. Now, Feynman had his character flaws, and I know he's been reappraised over the last few years, but as a scientist, as a communicator, as a physicist, the reason he's lauded so much is that he was such an incredible communicator and such an incredible physicist, of course. 60 Symbols I'll mention occasionally during this because 60 Symbols is great in terms of gauging sort of public opinion on certain topics. YouTube comment sections we'll get back to, of course. YouTube comment sections, I've got colleagues and friends who think that YouTube comment sections are just the condensed collective stupidity of humanity in one easy to find place, and many times they're right, but actually it's a really great insight into just what's the perception of science and what's the perception of physics. So, I can't remember when it was, 2 years ago maybe. Brady and I did a video, as you can see it's called, it was called Falsifiability in Messy Science. And I did a blog post after that video came out where I sort of went through the comments under that video. The blog post is called The Truth, the Whole Truth and Nothing But. The blog is called Symptoms of the Universe. You can find that blog post. And it's for PPP. It's a really helpful exercise to go down through those YouTube comments. I think we need to distinguish clearly between the messy creative process of coming up with scientific theories, a process which depends a lot on social factors and chance, versus the more structured and systematic process of testing them, which doesn't. That is unbelievably naive. The whole idea of testing in terms of doing the science, in terms of what gets published, in terms of what gets funded. I've had grant applications which are basically the same proposal sent to two different panels. For one panel it has come out right at the top, and for another panel it has come out right at the bottom, or very, very close to the bottom. Same proposal, same grant proposal. That is immediately telling you that it's not just about the quality of the science or the objectivity of the science or the data or the evidence. It's about the social dynamics and how this is appraised. So this cavalry come here is, this is a traditional perception, and I know it's going to wound him or her to hear this, but that's not how science works. This idea of complete and utter objectivity. I think I've hammered home that message enough. We work very hard to make it as objective as possible, but that does not mean that it's completely free of all biases and all social dynamics. Death of expertise here. So I've included that XKCD comic. You can pause and read that through. Take a little break now. Pause. XKCD will feature not infrequently. From one XKCD cartoon to the next. This is taken just a few frames from a longer cartoon, but it's this central comment that I want to get across and focus on. The wonderful thing about science is that it doesn't ask for your faith, it just asks for your eyes. But the problem is your eyes can deceive you. And not only can your eyes deceive you, you can go beyond your eyes, of course, and you can use very powerful instruments with very, very high precision. And they will give you results. But then it comes to interpreting those results. And I've seen a number of occasions, many occasions, whereby the same piece of data, you give it to a number of different scientists or a number of different groups, or even scientists within the same group, and ask them to interpret that data, and you'll get different interpretations. So, in what sense then is that scientific result, is the experiment objective, if different scientists can interpret the data in different ways? And then, of course, you'll say, well, as science evolves, then we get, closer and closer to the proper interpretation or to a general interpretation. But that's on the basis of consensus. And isn't that interesting? We argue that science is sort of free of these social dynamics, but ultimately reproducibility is key, and we're going on the basis often of consensus. And if a new result comes out that challenges the received wisdom, you have a much more difficult time to get that through, even though your experiment might be pristine in terms of the quality of the data and the quality of the interpretation even, and the quality of the fit to the theory. Okay, so the wonderful thing about science is that it doesn't ask for your faith, it just asks for your eyes. But the problem is, are our eyes good enough? Many of you will have seen this. I love this little demonstration. So you can see squares A and B there on that little chessboard pretty much look very dramatically different in colour. Now, the problem is this: if we just shade out everything else, so you just look at those squares, and all I've done here is basically overlay a black sheet with two holes in it, they're exactly the same shade. So our eyes can be fooled. We know this in terms of optical illusions. And the argument is, well, we can, we'll not rely on our senses, but we'll rely on instruments that will collect that data. But at the end of the day, we still have to interpret that data. This one is an old one. Some of you might remember this, some of you won't. This was very topical back about, 2014, 2015 when PPP started. I really like this because I'm in that minority, that 21% here that sees white and gold. Yet, this is the key thing, I know it's black and blue. You can load it into whatever image processing package you like, and you can see that the pixel values are black and blue. And yet I see white and gold. So I already know this, and yet there's a part of my brain that just will not let me see black and blue, even though another part of my brain knows it's black and blue. So the psychology here is very important in terms of how we take in data and how we interpret that data. And that's trusting our eyes. What about our ears? This is a really neat example. I'll play this through.
What you'll hear is a sentence, a spoken sentence, that's been transformed by a computer to sound like gibberish. So, any idea what they said?
No.
Okay. You can hear it one more time. Okay, now we'll hear the real sentence.
The Constitution Center is at the next stop.
Does it make sense that time?
Yeah, wait, was that the same?
It was the exact same sentence that you heard the first time.
No way.
It's the exact same sentence. Your brain is always using prior information to make sense of new information coming in. So once you know what the sentence is, when you go back and hear the distorted version, you can apply that information and it makes sense.
Isn't that bloody great? I love that. But this idea of continually updating your brain is what she says is your brain is what she says is your brain is always making use of prior information to make sense of new information coming in. And that means that, of course, we're going to interpret stuff through the lens of what we've already learned and through the lens of what we've already seen before or heard before or studied before. So this is, qualitative statement of Bayes' theorem, and we will be coming back to Bayes' theorem and prior information and the question of probabilities and how we update our probabilities on the basis of what's come before. We'll come back to that. In the meantime, I thoroughly recommend this post, which was a Guardian post, again a few years back, 2014 as well, but it's aged very, very well, and it's just as important now as it was then. Belief, Bias and Bayes, John Butterworth, who's at UCL, and written a brilliant book actually called Smashing Physics, which I also thoroughly recommend, about particle physics, Higgs, CERN, etc., etc. This is from all the way back in 1989, and it's the title, as you can see, is On Being a Scientist, and it's from National Academy of Sciences in the US, and as you can see, it was a committee that they commissioned on the conduct of science. They quote Peter Medawar, The Art of the Soluble, which is a great book. Scientists are people of very dissimilar temperaments doing different things in very different ways. Among scientists are collectors, classifiers, and compulsive tidiers uppers. Tidiers up. Many are detectives by temperament and many are explorers. Some are artists and others are artisans. There are poet-scientists and philosopher-scientists and even a few mystics. Wide range of different human qualities and human characteristics and human drives and human motivations. And yes, we do our best to be as objective as possible, but sometimes it's really difficult and sometimes we fail. To an observer of science, the presence of these human elements in research raises an obvious question. Science results in knowledge that is as solid and reliable as anything we know, which is true. Science and technology are among humanity's greatest achievements, having transformed not only the material conditions of our lives, but the very way in which we view the world. Yet scientific knowledge emerges from a process that is intensely human, a process marked by its full share of human virtues and limitations. And here's the key question. How is the limited, fallible work of individual scientists converted into the enduring edifice of scientific knowledge? That's a beautifully worded sentence and a beautifully worded paragraph. But that key question at the end is crucial. Here's some other questions to think about before the next synchronous session. These are the type of questions I'm going to be asking you to discuss, debate, argue, hopefully not come to blows with, which is a bit difficult in this virtual environment. But these are the type of things we want to discuss. Does science really prove nothing? How is scientific knowledge different from other forms of knowledge? Can we define the scientific method? Indeed, is there a scientific method? And how do we counter the death of expertise? Okay, that's it in terms of the asynchronous video. I look forward to the synchronous session on Monday. Have a great weekend. Try to think about some of these questions and let's have a fun discussion on Monday. It's an experiment for myself, an experiment for Penny in terms of just how this is going to play out. But if it's anything like in previous years with PPP, it's always been a very, very fun module, and I've actually had to call a halt to students discussing and debating and say, look, our time is up, we're going to have to leave now. So let's see if we're going to get something similar in the online environment. I hope so. Have a great weekend. See you Monday. Bye.